So this is my Facit 1004, which you know is a little bit different from your Facit CM216. I have a CM216, but as I told you, it's in the university in my office. I haven't gone there for a while now. So I'll show you what I meant in the email using this one. I removed the cover here today. You already notice there's a kind of a difference here for the reset levers. I don't quite remember. I think those two are different from the CM216. Those reset the accumulator and the counter registers here. So what I was trying to say to you, to tell you, is that the mechanism for the advancement of the counter works like this, should work like this. You see, when you crank it forward, it will move naturally for 1, 2, 3, and etc. At this point, if we crank it backward, it will come back to 0 and then go to negative to all nines. So again, if we crank it forward, it will go forward naturally, and once it has been moved forward, it keeps the mechanism set in the same way. So if you crank it backwards, it will go to 0 and then to all nines, following the same direction of movement. Okay, so let's reset it, not just put it to 0, but reset everything here and here. And now if I crank it backward, you'll see it goes to -1 with this little red window showing the red square, -2, -3, and etc. If I go forward now, it's set in the backward motion. So I'll get back to -1 and to 0. The red flag still stays on, and of course if I go further ahead, it gets to all nines. So there's a difference here. There's something in the movement of the main crank that makes the mechanism set in the definite direction. So let's reset it, and notice this. If I go a little bit forward and then regret it before the lock takes place, before the lock operates, and try to go backward, it will still allow me, but the mechanism is already set on the positive. So you go to all nines and no negative flag. You see? So it's a little piece that's embedded right behind, right under those gears here connected to the main crank that sets this operation to either mode. There's also a difference that you can notice here when you look at the carry rotors right here, the set of discs here with pins. If we move forward, if we move forward, there are two halves of these. One that is connected to the counter register, and the other to the accumulator register. So if we move forward, both carry sets of carry gears, I don't know how to call them, will rotate in the same direction. But if we reset everything and crank it backwards, you'll notice that the carry rotors will spin in different directions. You see here, they're spinning, one spinning forward and the other backward. Okay, so this is an important part of everything that's making this thing work with the counter operation. Of course, the counter reset is here. It's also connected to everything in this part of the mechanism of the machine. And you will notice that the carry rotors right here rotate around the shaft you pointed out to me in your photo, which is locked in place by that U-shaped piece. So the shaft should not move, but the rotors should spin around this shaft. Also notice there is a mark here. This line here indicates it's a timing mark made at the factory for the assembler, for the technician to assemble the machine, to know where to set, where to position the carry rotors so that everything works correctly. So if you want, if you anytime decide to try to disassemble the machine, take good notice of those details, as they are crucial for you to be able to put everything back together as it was and make it work. Of course, parts like this one that command this mechanism are almost impossible to reach from here. I can't even see it to remind me myself what it does it look like. But when you push the main register to the left, you can see that there's nothing that allows you to see through that. There's other pieces in the way, so you can't really see what's going on. But that's well, that's one of the many intricate details about those machines that made them so fascinating. So of course, let's try to make them work again. So it'll be important for you to achieve that. Okay, I'll try to find, see if I can remember, and looking at my notes, what are the parts that are used to command this kind of behavior that I showed you, and I'll point those out to you in photos later on. Okay, so that's it. Feel free to come back and ask anything you need. I forgot to mention that the part that probably has given me the most trouble when trying to make everything work again was this set of plastic gears that comes here back in the back. The CM216s are a little different from those ones in the 1004, but their intention is the same. I don't know if you caught on that yet, but the idea is for you to make some operation here and obtain some result, and then let's say you want that result to get back to the input register and you don't want to type it back in. So all you have to do is use that extra lever here, and it will be transferred to the input register. Okay, so there you go. There it goes. All right, this for you to make this work, the machine should be in top shape. Everything should be working perfectly, so this does not lock up the machine. So be careful with that, if you will. Okay, that's it. So let me take the opportunity to show you how the division works in this machine. Okay, so here it goes. Let's get an input. 16384. We have to move it all the way to the left and add. Now of course the counter has a 1 here. We don't want that, so I'll reset the input and reset the counter as well here. Now I put the divisor to 56. We move it all the way back, and then we subtract. We move the crank backwards, and then it goes. It gets negative and it sounds the bell. The negative indicator is here. Never mind that. We have to move this one column to the right, and then we keep subtracting until we hear the bell. There you go. 1 forward, move back, and then subtract again. In this case, there's no remainder, so there's a result, 64. All right.